Welcome to Science Access. In today's class, I'll be introducing you to the topic rectilinear motion. If you know you're new to this channel, please kindly subscribe. Now, what do you understand by the term rectilinear motion? The easier or the simplest kind of motion anyway is simply the movement of an object in a straight line. Listen, it is defined as the movement of an object in a straight line. An object moves from point A to point B in a straight line. That is what rectilinear motion. And there are three key features or characteristics of rectilinear motion. Number one is that it moves in a straight line. Number two is that the direction remains constant or it does not change direction. Let me put it this way. Object can move from here to here. It can stop, no problem. It can even move backward, can reverse, no problem. But it cannot change its direction. So it must move in a straight line. The direction remains what? Constant. And lastly, the speed or the velocity. Note, the velocity may remain constant or may increase or decrease, or it may vary. For example, the object can start moving at a certain speed, or it can start moving with the same speed, with same velocity to this point. Or it can decide to start slowly and increase what? The velocity as it moves. So the speed may be what? Varies, or it may remain what? Constant. Please take note of that. Now, some example of rectilinear motion is if I decide to drop this marker down, I decide to leave it before straight down, that's rectilinear motion. A car driving in a straight highway between cities, that's rectilinear motion. Or even a train in a straight track, that's also rectilinear motion. Why is it important that we study this motion? Why is the study of rectilinear motion important? Take note. It's simply is the easiest kind of motion that you can study or you can analyze mathematically. It provides the foundation for even exploring other complex kind of motion. Notice that even the concept of speed, distance, displacement, velocity, and all that, they are derived from what? The simple concept of rectilinear motion, because rectilinear motion is the easiest kind of motion that you can study. We have three types of rectilinear motion. We have the uniform rectilinear motion, we have the uniformly accelerated rectilinear motion, and non-uniformly accelerated rectilinear motion. Please take note again. We have the uniform rectilinear motion, we have the uniformly accelerated rectilinear motion, and non-uniformly accelerated rectilinear motion. All right, let's take a look at the first one. The first one I made mention of the fact is the uniform rectilinear motion. Now, it's a very simple concept. The word uniform means that the object moving, it covers equal distance at equal time interval. For example, the object moves from point A to point B, from point B again to point C, from C to what? D. Now, it moves from this point to this point. It moves, let's assume that this point is 20 meters. It moves from this point to this point in 10 seconds. Move another 20 meters again in 10 seconds. Another 20 meters again in what? 10 seconds. So you realize that it's a uniform rectilinear motion, because it's moving equal distance at equal time interval. What can we deduce from this? You notice that the velocity is constant. What is velocity? Velocity is what? Distance or displacement all over time. Over what? Time. The velocity of speed is what? Constant. Now, if you try to calculate the velocity from point A to point B, what will you get? 20. Use 10 to divide this. You have what? 2 meter per second. If you calculate here, you also have 2 meter per second, because it's also 10 divided 20. And here you have 2 meter per second. So you realize that the speed or velocity is what? Constant. Please take note of that. Acceleration is 0. Now, number one characteristic again of this uniform rectilinear motion is that the speed or velocity is what? Constant. I did explain that. Now, acceleration is 0. How do you calculate acceleration? Acceleration is change in velocity, right? Now, but in this case, is velocity changing? No. So if Remember, acceleration, you minus final velocity minus what? Initial velocity all over what? Time. But in this case, it's 2 minus 2 because velocity here and here is the same thing, right? All over what? Time, which is still, which this is actually what? 0 all over what? Time, which your final answer is what? 0. So acceleration is what? Constant. Velocity, sorry, acceleration is what? 0. Velocity is what? Constant. Or speed is what? Constant. And the last thing that we should note as usual is that it moves in a straight line. Now, the second kind of rectilinear motion we are going to talk about is what? The uniformly accelerated rectilinear motion. But before I talk about that, how do uniform rectilinear motion, how does the graph look like? Something like this. And you have, this is V in meter per seconds, and this is what? Time in seconds. Now, realize the value of the velocity is the same, it's constant. Let's assume that we label this place as 0. Label this place as 0. Here is 1, 2, 3, 4, 5. Now you realize that the value here, the value of the velocity is what? Constant. All right. So it's just a reflection of what I've already explained. So let's talk about the second kind of motion, which is what? 2 uniformly accelerated rectilinear what? Motion. Uniformly accelerated rectilinear motion can be defined as the motion of an object moving in a straight line with constant acceleration. Notice that word. Uniformly what? Accelerated what? Rectilinear motion. It's moving in a straight line with constant what? Acceleration. All right? Take note of that. For example, I have to clean this figure here so that we can use this simple stuff to illustrate this again. All right? So let's assume that for the first 10 seconds, the car traveled 20 what meter. For the second 10 seconds again, the car traveled what? 40. Another 10 seconds, the car traveled 60. Let me just add to this. Another 10 seconds, the car traveled what? 80. Now, there's something unique about this. You notice that the velocity is changing at a constant rate, but the acceleration is constant. So the key features of uniformly accelerated rectilinear motion, as usual, is always in a straight line. The second thing is that the velocity is changing at a constant rate and the acceleration is constant. Now let's prove that the velocity is changing at a constant rate. What is the velocity here? This velocity is changing displacement all over time, which is use this to divide this. What will be your answer? Here is 2. Here is 4. Am I correct? Here is what? 6. Here is what? 8. So here is 2. Here is 4. Here is 6. Here is 8. Do you notice that the velocity is changing at a constant rate? Take note of that. It's like you're adding 2 each. Now let's calculate the acceleration. Acceleration is now change in velocity all over time, which is initial velocity, remove initial velocity from final velocity. Let's just use this formula here, which is V. V is the final velocity minus what? Initial velocity all over what? Time. So let's calculate, let's use this bit as our final, and this is our initial. We now have 4 minus 2 all over what? Time, which is 10 seconds. What will be your answer? Answer will be 2 all over what? 10 equals to 0. This is 1 all over 5. 0.2 meter per second was square. This is the acceleration. We just use from here to here. Now let's use from here to here. You now have 6 all over minus 2 all over what? 10. You still have 2 all over what? 10. 1 all over 5. 0.2 meter per second. If you use here and here, you have 8 minus 6 all over what? 10. So you still have 0.5. So you notice that no matter if any 2 points you use, once you calculate the slope, you're going to get the same acceleration. That means acceleration is constant. The velocity is changing at a constant rate. It's also in a straight line. So this is actually the key features of the uniformly accelerated rectilinear motion. Please take note of that. And the final one we are going to talk about, before we talk about the final one, how does the graph of uniformly accelerated rectilinear motion look like? If you want to put the velocity time graph, velocity what? Time. Time is seconds, velocity is what? Meter per what? Seconds. You notice that the velocity is changing. You have a straight line. 2, 4, 6, 8. You have a straight line. Velocity is changing per time. Well, what about if you want to put the acceleration what? Time graph. Here is acceleration, which is in meter per what? Second square. Here is what? Time. Seconds. Now, acceleration is constant. Remember, when the velocity was constant here, you have a straight line. So when acceleration is placed in this place, you have a straight line because the value of the acceleration as we calculated is not actually increasing. It's remain what? Constant. So the velocity time graph for uniformly accelerated rectilinear motion is this straight line you see here. Velocity is increasing at a regular what? Time what? Interval. All right. Why the acceleration time graph? As you can see from this place, acceleration is actually what? Constant. And the last one we are going to talk about is the what? None. In this place, just put none. So just put non-uniformly accelerated rectilinear what? Motion. Non-uniformly what? Accelerated rectilinear motion. So let's just clean this place so that you will not have to make mistake. So you have here non-uniformly accelerated rectilinear motion. Now this one is quite easy to understand in the sense that in this case, the acceleration is not changing at a regular interval. This motion of an object in which the acceleration is not changing at a regular what? Interval. All right. So we can have a graph that is like this. That is like this. Or taking any pattern because the acceleration, the velocity is not changing at a regular what? Interval. So the velocity is actually varies. And in this case, another characteristic is that the acceleration is actually changing too. Acceleration or deceleration is changing too. So first, it has to be in a straight line. You know that because it's a rectilinear motion, okay? But in this case, the acceleration is changing. It's not constant like the uniformly accelerated. And the last part also is that the velocity is not actually changing it's not constant. So it's not changing at a regular interval. So please take note. This is just an introductory class to the rectilinear motion. So in my next video, we'll be talking about some terms such as the displacement, distance, speed, velocity, acceleration, and all that. We'll be explaining it, and we may start talking about calculations. Very easy topic. All right. Thank you for watching.